So far, we have dealt with kinematics, the study of motion and its properties. This is when we move into kinetics, which is the study of forces. So let's get into it. Forces are described as a push or pull exerted on an object, and they are in units of newtons. For example, a force of 10 newtons is applied. Newton's laws are the backbone of physics. They are fundamental to understanding how forces affect objects. Newton's first law states that once an object is in motion, it will remain in motion unless another force acts on it to counter that motion. Basically, objects resist changes in motion. If it's still, it will remain still. If it's in motion, it will perpetually stay in that motion. It will take a force to change its current state, to either speed it up, slow it down, or change its direction. A way to visualize this is if an astronaut in space throws a tool. The tool will stay in motion forever unless a force, like the one from a collision of a satellite, acts on it. Newton's second law states that applying a force to objects with a certain mass causes them to accelerate. The more massive the object, the more force it requires to accelerate it. This is where Newton's second law equation comes into place, F equals ma. Imagine you have a shopping cart and it is empty. The force it will require to start moving will be minimal. Now let's imagine that same shopping cart full of groceries. In this case, it has more mass, which will require more force to start moving it. Newton's third law states that every action has an equal and opposite reaction. This law holds in any scenario where there is contact between objects. Basically, a force always emerges from touch. To illustrate this, think about standing on a boat that's stationed on a shore. There will be a force on your feet from the boat, and there will be a force on the boat from your feet. These two will have the same magnitude but opposite directions. There will also be a force from the shore on the boat and a force from the boat on the shore, which again will have the same magnitude but opposite directions. The fact that they have the same magnitude but are countering each other in directions is what allows for them to cancel out, meaning that no force overpowers the other. Therefore, the objects are in static equilibrium. That was the end of this video. I hope you learned something, and thank you for watching.